Okay, today we're going to be looking at the intersection of a line and a quadratic. So let's look at our three possible situations. We could have our quadratic curve and we could have our line cutting at two distinct points of intersection. Or we could have our quadratic and our line just skims past it and there's one point of intersection, and that is the line is tangent to the curve. Or we can have our quadratic curve and our line and there's no points of intersection. Now before we were looking at these situations before, and we used we solved their simultaneous equations. Now, to find the points of intersection, we're going to use the simultaneous equations, but we're going to also add in, we're going to solve the discriminant for the simultaneous equations. So remember, ax squared plus bx plus c equals 0, and from the quadratic formula, we've got b squared minus 4ac. This is the discriminant. So for b squared minus 4ac greater than 0, we'll have our 2 points. For b squared minus 4ac equal to 0, we'll have 2 equal real roots, or 1 point of intersection, and for b squared minus 4ac less than 0, there's no points of intersection. So let's have a look at this in an example. So we've got the line y equals x plus k, and we have the quadratic curve y equals x squared plus 5x plus 2, and we want to find the value of k for the line to be a tangent of the curve. So that would be 1 point of intersection. So let's say y equals this and y equals this. So we're going to put these as equal. So x squared plus 5x plus 2 equals x plus k. Now we're going to bring it over and put it into the standard form of a quadratic equation. So we've got x squared plus 5x minus x will be 4x plus 2 minus k. We'll put this in brackets. That's going to be our c. So now we're going to, when the line is tangent to our quadratic curve, we will have b squared minus 4ac equal to 0. So b is 4 squared, minus 4 times a, which is 1, times c, which is 2 minus k, equal to 0. So that's going to be 16 minus 8 plus 4k equals 0. So 4k, which is 0, will be equal to minus 8 So k must be minus 2. Let's look at another couple of examples. So again, we're going to be looking for the values of k for which the line y equals kx minus 1 intersects y equals x squared minus 2x at two distinct points. So again, we'll put these equal to each other. So we have x squared minus 2x equals kx minus 1. So bring everything over to the same side. X squared minus 2x minus kx plus 1 equals 0. So we'll have x squared minus k plus 2x plus 1 equals 0. So for the two distinct points of intersection, of b squared minus 4ac has to be greater than 0. So this is b. So minus k plus 2 squared minus 4 times a is 1 times c is 1. Is going to be greater than 0. So the negative is going to get cancelled out. So we'll end and we'll expand this bracket. So we'll have k squared plus 4k plus 4. Then we've got minus 4 greater than 0. So these will be cancelled out. So we'll have, putting this in brackets to the k out, we'll have k plus 4. These cancel. Greater than 0. So the critical values are going to be, if you think of this line representing your k-axis, is going to be when this equals 0. So that's going to be when k equals 0. So that's going to be 0. And when k, actually we'll make this 0, and when k equals minus 4, and we'll make this one minus 4. But we want this when it's greater than 0. So let's, the x squared here is the a coefficient is positive, so it's going to be this shape of a quadratic. So this is positive, and this is negative. So k must be less than minus 4 and k must be greater than 0. Let's look at another example. So we want to find the value for k when 2x plus y equals k and when x, y equals 8. Now, we're going to rearrange this so we've got y. Y equals k minus 2x. Now if you look here, y here has been multiplied by x. So if we have xy, we would have x k minus 2x, and that has to equal 8. So we are going to solve this. So we're going to multiply out our bracket. So we'll have kx minus 2x squared equals minus 8. Equals plus 8, sorry. And rearranging this, we'll have 2x squared minus kx plus 8 equals 0. Now for b squared minus 4ac, we want this to have no distinct roots this time. So this has to be less than 0. So b is minus k, so it's going to be k squared. Minus 4 times 2 times 8 less than 0. So we'll have k squared less than 64 less than 0. So that works out as k plus 8, k minus 8 less than 0. And now the critical values, again, we're going to look when k is 0. So k is going to be 0 at k equal minus 8 and k equal 8. So we'll have minus 8 and we'll have 8. Now our a coefficient here is positive, so again we're going to have this shape of quadratic. It's negative here and it's positive here, but we want to know when it's negative. So k must be between minus 8 and 8. I hope that helps.